Let's look at finding zeros of a polynomial. For example, let's find all zeros of f given that 2 is a zero and write f as a product of linear factors. Now, because 2 is a zero of this polynomial, that means that x minus 2 is a factor of f. Which means that x minus 2 will divide this polynomial f of x evenly. That is, there's a polynomial q of x such that f of x is equal to x minus 2 times q of x. And we can find q of x by dividing f by x minus 2. So let's do that. F of x is x cubed minus 4x squared plus x plus 6. Now x goes into x cubed, x squared times, and x squared times x minus 2 is x cubed minus 2x squared. And now we subtract. X cubed minus x cubed is 0, and negative 4x squared minus a minus 2x squared is negative 2x squared. And we still have this plus x plus 6. And now x goes into negative 2x squared, negative 2x times, and negative 2x times x minus 2 is negative 2x squared plus 4x. Again, subtracting, we get negative 3x plus 6. And x goes into negative 3x, negative 3 times, and negative 3 times x minus 2 is negative 3x plus 6. And subtracting, we get 0. Which shouldn't surprise you because x minus 2 is a factor of f. Therefore, this is the quotient q of x. Which means we can write f of x equal to x minus 2 times q of x, which we just found to be x squared minus 2x minus 3. And now we can factor q of x. That is, f of x is equal to x minus 2 times, and q of x factors into x minus 3 times x plus 1. And we've written f as a product of linear factors, which is one of the things we wanted to do. So it remains to find all the other zeros of f. But by writing f as a product of linear factors, we can easily find the other zeros of f. That is, f of x is equal to 0 means that x minus 2 is equal to 0, or x minus 3 is equal to 0, or x plus 1 is equal to 0. Which means x is equal to 2, which we already knew, that was the given 0 up here, or x is equal to 3, or x is equal to negative 1, which are the zeros of f. And this is how we find the zeros of a polynomial given 1, 0. Thank you, and we'll see you next time.